Question number 5, Newton's laws of motion, MCQ, book Pathfinder. A uniform rope is tied between a nail A on the wall and a nail B on the ground. So these are two nails A and B. One is on wall, the other is on ground. The rope, without touching the ground anywhere, assumes a curved shape known as catenary. Tangents at the ends A and B of this catenary makes angles alpha and beta with the vertical respectively. Which of the following conclusions can you make? Horizontal component of the tensile force in the rope is uniform. Vertical component increases with height. Angle alpha can be greater than beta. Angle alpha cannot assume a value 0. So we have a wall, ground. There are 2 points A and B, and there is a rope. The rope makes an angle alpha and beta with the verticals at the ends as shown. Now consider a small part of this rope. And let the tensile forces at its ends be T1 and T2. W is the weight of this part of rope. Horizontal components are T each. Why these components are equal? Okay, these components are equal because if they were not, this part of rope would move horizontally, would accelerate horizontally. And since every part of the rope is stationary, so it has a net force equal to 0 in any direction. So in a horizontal direction, it's having a net force 0, and therefore these two forces must be equal and opposite in direction. So these T's must be same, otherwise there will be a net horizontal force and this part would accelerate. So the option A is correct. Horizontal component of the tensile force is uniform. Now I'm taking the angle made on the left hand side of this part as alpha, though it's not equal to alpha, it's just representing the angle on the left hand side. So I'm just denoting it by alpha. So alpha here stands for the angle made on the left side of the part considered. And similarly, I'm taking beta as the angle made on the right side of the part. So the vertical components will be T cot alpha and T cot beta. I'm not using T1. If I used T1, it would be T1 cos alpha, and the vertical component here will be T2 cos beta. But rather, I'm using T to find this vertical component as T cot alpha. And similarly, here we have vertical component as T cot beta. So now, equating the vertical forces, we have this equation. T cot alpha is balancing W plus T cot beta. And it's obvious from here that T cot alpha is more than T cot beta. So the vertical component is increasing with height. Yes, it's true, because the vertical component with height has to be more because it has to balance the weight of the part as well along with this vertical component at the lower height, because it has to balance the weight of part as well. So from here we have cot alpha more than cot beta, or alpha is less than beta. So option C is incorrect. It is saying the opposite of it. Angle alpha can be greater than beta. No, it's just the opposite. If alpha was 0, then there would be no horizontal component at that point. Then how would this horizontal component will be balanced on any part? Option D is correct. It's saying angle alpha cannot assume a value 0.